What's up everyone? Today we're going to go over word search 2 or Leetcode 212. Now the input is going to be a 2D grid of characters like this and a list of words, and the output needs to be all the words that can be found on that grid. Now how that happens, how do we get oath, oat, and eat? We have O-A-T-H, and we also have O-A-T, and we also have E-A-T. So the conditions are we can go up, down, left, or right, and backwards also, like E-A-T, backwards. No diagonals, and we need to return all of them. It doesn't really matter the output order of what we're returning them, but they just need to all be contained there. Now there is a word search 1 version of the problem. I recommend you check that out first so you get an intuition, because that one is fundamentally different from this in the sense that while word search 1 is just using backtracking, this one is going to be using a backtracking and a data structure known as a trie. Before I get into the code, I'm going to explain how the trie is looking and how it actually fully looks like for this example, and how we're using that for fast lookup. So just brief explanation about a trie. It's used for fast insertion and searching of words as lowercase letters. So I'm going to implement the trie using an array, but you can also implement it using a hash map. And I made a slight tweak to my trie data structure to answer this problem, but overall it's pretty much the same way as a standard trie. Yeah. Okay, so let me first draw what the node looks like. So a trie node looks like this. It's going to have an array of other trie nodes, and it's going to have a boolean, usually is word, and it's initialized to false. And this is the small tweak I made. String is word, and this is going to be set to null. Don't worry about these two completely yet, because you'll understand it when I actually draw out the structure. But let's look at this array first. So every block in here, there's 26 of these, is responsible for one letter of the alphabet. So let's say, for example, I'm trying to insert the word A. I'm trying to insert a word that begins with A. So when I write something like this, what this means is that the difference in ASCII values between my character and A is going to be the index of this array. So if there is a word that begins with A, the trie node pointers that go from this index are going to be responsible. So this one is going to be an A. Now if I have a C, the difference in ASCII values is like that. So this is another trie node, and this is another trie node. That's how the tree-like nature of this is going to be built. The is word and the word are variables that are responsible for keeping track of a valid word that has been built using a given input. So let's see what this is going to look like for that. Now we have a root node, and that begins by O, just put N for null and F for false. So O, A, this is N for null, and this F for false. O, A, T, H, this is N for null, and this is F for false. And this is where I'm going to actually hold the word itself oath, and I'm going to write T for true, because this node is the one that's responsible for keeping track of my word oath. So these are just going to be null. But you see that OATH is responsible, is being tracked by the 5th trie node. So even though the word only has 4 letters, we have 1, 2, 3, 4, 5 total nodes. Let's see what P, E, eat, rain, and oat looks like. So element OP, so P goes here. This is null. This is false. E, N, F, T is null. No. E, P, E, A. Oh, sorry, P, E, A. Yeah. P, E. This needs to be A. And then this one is going to be responsible for saying P, and this one is going to say true, and this is going to be just null nodes. Eat is going to be E, this is null, this is false. A, T, E-A-T, this is going to be true, and this is going to be empty, or no. Now we have rain. See, rain goes here. This is null, this is false. A goes from here. Null, false. I, N, and then this node is going to be responsible for having the word rain and true. These are just empty. Hold on. Now this one is interesting. Let's pay attention to oat. We see that OAT is already included because of oath. So OAT, all we have to do is update this one to say OAT, and then make this one true. So now you can see how there's a lot of reuse the trie data structure is built. If we're reusing the same letters or parts of words or substrings. Now that you have an idea of what this is going to look like for this example, let's get into the code of the actual trie nodes itself. So the class trie node, I call it Tn, is going to be an array of trie nodes, and it's going to be initialized to size 26 for 26 letters, and then it's going to have a string word is null. We're going to have boolean is word is false. Then let's have the constructor for int I is equal to 0, I is less than AR dot length, and then I plus plus, and then AR of I is set to null in the beginning, and then word, oh actually initialized these already, so that's fine. Yeah. Okay. Yeah, that's the complete node. So we have our array initialized to null, the word is null, and boolean is initially false. Now we're going to use this to make our trie class. So class trie, we're going to have a root node always, and then we insert and search. Those are the two basic. In this problem, I'm not really going to use the search method, but I just write it for clarity's sake. So void insert string str. We're always going to have a reference to the root node, so we can build on the tree. Then we have for int I is equal to 0, I is less than str dot length plus plus, and then this is the part, just pay attention here. Index is equal to str dot char at I minus ASCII value. So for example, like oath, right? OATH. O minus this one is going to be some number, and O minus A is going to be some number 0, and O minus A, and T minus A, and then H minus A. So what we want from this index here is the offset of the ASCII value, so we know where in the array we need to initialize the new trie node. Once we have that, then we say if cur.ar of index is null, then cur.ar of index is going to be set to new trie node. And then we just pass the pointer along the bottom of the tree and continue with the string ar of index. And once we're at the end, all we have to do is say cur.isWord is true, and cur.word is going to be str. That's how we insert a string. Now, how do we search a string? Well, it's going to be the same code, but we are going to modify it slightly to return true or false. For int labeled 0, I is less than str.length. Then we have int index is str.char at I minus A. If cur.ar of index is null, then cur.ar. Oh no, if it's null, then we return false, because what that means is whatever word we're trying to find is not in our trie class, in our trie data structure. And otherwise, as the same thing, we just return we continue with what's going on. And then the return is actually going to be if the cur pointer is not null and the cur is actually keeping track of a valid word. So that's what the insert and search look like for a class of trie. Now, cool. Now that we've gone over the trie part of the question, let's go over the backtracking part of the question. So in backtracking, it's generally just like this, right? Backtracking, we make a change, recursive, and we undo change. Most backtracking is pretty much just this. Now let's see how that looks like for our characters. So I'm going to redraw the trie just very quickly. P element OP. eat, and then rain. That comes out to be true. And then oat, O-A-T, is just going to reuse this. So O-A-T, true, and then that one. I just did that quickly so we can focus on the backtracking without getting confused. Now, in the beginning, what we do is we go through all of these letters one by one, and we can see from our root if the character we're visiting is actually part of the trie. So when we look at O, we see that O is part of it. So what we do is first we visit it, and then we set it as temporarily visited by using this hashtag symbol. And then we transfer control over to this node. So O is pointing to this node, right? This is the node that's responsible for O, and we grant it control. So what we do is, after granting it control, we are going to check up, down, left, or right, and see if the letters in here are surrounding O. So first we go up, and we see it's out of bounds, doesn't matter. We go down, it's E, it's not in here, so we don't care. Left, it's out of bounds, doesn't matter. But when we check on the right side, we see, okay, it's part of A. And then when A is going to start taking control, now that we've finally started looking for a successful word, let's use a set to keep track of all the words we found, which are valid words of the trie. So we have a set, and then we see that, well, OA is not a valid word, right? There's no true or false or anything like that. So then once A is successfully taking control of the stack, it's going to set itself as temporarily visited with that hashtag symbol, and then it's going to transfer control to T. Now A is also going to check up, down, left, right to see which letters around it are potentially in this node. So up, again, it's not valid. Left, it's going to see, well, O is already temporarily being visited, so it's just going to skip it or return. And it's going to check its right side, and it's going to see, is there an A in here? No, it's not. And then it's going to check down, and T is going to say, okay, cool, I'm in this. So let me set this as visited. And then T is going to say, I'm going to pass control over to this node, and let's check this node to see if a valid word exists. Yes, we see OAT exists, so we can add it to our set. Now T is going to check its neighbors up, down, left, right. Up is already a visited, so we don't care. Left is an E. E is not in here. T is going to check its right side, A. A is not in here. T is going to check its downside, H. H is in here. So H is a valid node. So now H is going to take control, the cursive stack, set itself as visited, and H is going to say, okay, let me go over to the node that I'm pointing to, and let me see if OATH is a valid word. Let's see what word is in there, OATH. So cool, let me add oath in here. Now H is going to check up, down, left, right. Up is already a visited node, forget about it. I, there's no I in here. K, there's no K in here. F, there's no F in here. So it's done going through the back. Now we undo the changes we made. So let's erase this. Cool, so we already have oath and oat in our set. So what's next? We go over to A. Well, A is not in here. A, the second A, it's not part of the root. N is not part of the root. E is not part of the root. T is not part of the root. A is not part of the root. E is part of the root. And the same way we did it for oath and oat, we go EAT and check the point for that. So briefly, what it's going to look like is this is visited, up no, down no, right side outside, and A is valid, and it's going to see is there any word in here that we can add to our set. There isn't, so it's going to check up, nope, visited, K is not in here. Of course, this goes to visited, and it's going to check on its right side. Is T part of here? Yes. T is going to take control. It's going to set itself as visited, and it's going to pass the control over to this node. And eat is a valid word, so we add EAT here. And then T is still going to finish up the recursive check. A is not part of this one. E is not a letter in here. H is not a letter in here. And on the right side, it's simply a same visited. But we have to finish up the backtracking and undo our changes. Okay, cool. Now that you've got the intuition of how try and the backtracking are combined together, let's get into the code. So the input, I think, is just a list of strings and or an array of strings and this board. So what they want is an array. I think a list of strings. I just call it search to a board of characters. And a string array. I think they call it words. So what we do is first go through these words and add them to our try. So try class, new try, and then for string s through words, tr.insert s, and then let's get a reference, a root reference to our try. Okay, so now our try is populated. What else? Okay, let's have a set. So prevent any duplicates. Set, call it res, and new hash set. Okay, I think that's what we have. Now we just iterate through our board. And let's check each character each time. So board, let's pull that character out, I of j, and see if our root.ar c minus a is not null, which is a very fast way of checking if a letter exists or not, if words begin to exist or not. Then we can recursively call our function. So we pass in the board, we pass in I and j, we pass in the set, we pass in the root, and we pass in the letter C. And let's close our for loops. And we're going to trust our DFS function takes care of it. We'll get into the DFS function in a second. And then we just return new array list. And we pass in the set collection. Oh, not the result. I called it result, yeah. And that's going to be kind of the main main function that's taking care of all the moving parts. Now let's look at the other parts of the code. Now anytime I do these 2D grid type problems, I always like to take help of a couple methods and arrays. So I'm gonna make use of a Boolean outside function. So it's gonna be a character board. What this does is it quickly allows me to know if a point is within the grid or not. If I is less than 0, or I is greater than or equal to board dot length, or j is less than 0, or j is greater than or equal to board of I of length, then return true. Else return false. And remember I said we have to go up, down, left, right. So for that, it's just a global variable, so we could have int x, int y. This is a check up, down, left, right. So -1, 1, 0, 0 like that. It's going to be that one, -1, 1. So let's see which direction that's going. This is going left. This is going right. Oh no. X's. This is going up. This is going down. This is going left. This is going right. Up, down, left, right. Okay. So we have our helper method and the global variables. So we went over the main one, and we went over the outside. We went over the arrays of x and y. Then we went over the trie itself. I wrote the code for the insert and the search. So now all that's left is the main part, which is the DFS. We have DFS. Let's recall what we passed in. We passed in a board, then we passed in the coordinates, then we passed in the set of strings result. Then we passed in the trie node. I'll label it current, and then passed in the character C. So anytime we're doing recursive functions, we should always take care of the base cases first. Now, if you recall when I was explaining with the board, what were some of the things that I did? Well, I made sure that if I'm I return immediately. I don't want to do that. And if I'm trying to visit a letter which has already been visited, or it has the hashtag symbol, return. And the other one is if I'm trying to visit a letter which is a non-valid in the trie, which means it's a null, and the node that it's responsible for is null. The node that the letter responsible for is null. So let me write the base cases for that. If the board of I of j is already been visited, or the current dot ar c minus a is null, return. Yes, I know that out of bounds is also a condition where we're returning, but we can just write that in the for loop that I'll show you. Now let's think about the backtracking part. How does backtracking come in? Remember I said backtracking is you make a change, recursively call stuff, and you undo that change. So what change are we doing here? First, I would call it cur. Let's see, cur is going to be set to cur dot ar c minus a. What does this do? Remember I said when O begins and it passes the control over to A, that's what this is doing, because O is already okay, yo, actually let me set this one. So let's make the change first. So character C oh yeah. What can I call this? I'm gonna call it T, yeah. Character T is extracted from board of I of j, and then board of I of j is going to be set to this one, and then we can now say cur is going to be set to cur dot ar of what is this one? T minus A, yeah. So we put that there. Now T is currently O, and then O is passing the pointer over to A. Now once this is here, what we can do is begin our up, down, left, right check. So for int k is equal to 0, k is less than x dot length, k plus plus, int row is going to be I plus x of k, and int co is going to be j plus y dot k, y of k. And if we're outside the board with these coordinates of row and co, then we just continue. Otherwise, we can recursively call our board and I, and no, not I. We're passing in row, co, and then there's a result, and then cur, which has been updated here, and then this character T, which is going to be the next letter that's being passed in. Now you might be going, wait a minute, how are we keeping track of the letters we've already found? Well, remember that once we pass the control over to cur, all we have to do is all we have to do is if cur is not null and cur dot is word is true, then all we have to do is add it to the result. Cur dot result dot add cur dot word, and that's where we're actually adding our words to the resulting set. Once we do that, it's very simple. All we do is undo our change. So board of I of j is going to be set back to T. So that's pretty much the code for how you do word search 2. If you like the video, please like it and comment below what you think, and please subscribe. Thank you for watching.